Okay, I hope you can see the screen. What I'm gonna do, once you download the rent Excel file, I want to import. Go to your computer, go to the folder, select, and then when you select, just to continue to click next, 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 and you will have file data in your RapidMiner repository. Looks like this. So let's see what it looks like. So once you click, your file looks like this. First column has rent, second beds, bathrooms, square feet. So when I want to go back to design and let me drag it to process and let's connect it to the result. And I want to run, see what it looks like. Okay. The results look same. It's the rent, beds, bathrooms, and square feet. So let me begin. I want to go back to design view and let's begin from here. So I hope you already read all the tutorial and this is what I did. So let me go to. I want to select retrieve rent, and I love to predict rent by number of bedroom, number of bathroom, and square feet. To do that first, let's select attribute. So when you click the select attribute, I'm gonna select all, but let's see what it looks like. Go to subset, and here, bathrooms, beds, rent, square feet. So we can select all, but let's just practice one by one. I want to add bathrooms, bed, rent, square feet. Okay. And then I'm going to select the role. So I'm going to set role, and I have to decide which is our target variable, what we are predicting. So I'm going to select rent. We are predicting rent price. So target role will be label. So label means we are predicting rent using rest of variables, three variables. After that, I'm going to use linear regression. Here you can see linear regression. Okay, it's good. And then I hope you read my tutorial. My tutorial also have apply model. The apply model means based on this regression model, I want to test it with other, separate or sometimes with the same data. In this case, I don't have any new separate data. I want to use existing data. Right now, as you can see, apply model require two data sources. So one can be trained, the other one can be tested. I don't have any separate testing data, so I'm just going to simply say, okay, use the same data. This is what I mean. This is what I mean by connecting linear regression model data to apply model. Okay, once you've done this one, I want to test whether this is a good model or not. So we're going to use the performance regression. So make sure when we select the performance, so let me show you example here. When you type performance, you see here many performance, classification, binomial, regression, cost, ranking, but we're going to use this one, regression. Of course, RapidMiner already know you're using regression, you'll recommend this. So I'm going to connect the label, I'm going to connect this data, and then I want to see only performance here. And among performance, when you click performance, there's so many performance measure here. So root mean squared error is already selected. You can select whatever you want, but to save time, we're gonna use only squared correlation. In addition to root mean squared error. I hope you read the tutorial and reading. So hope you know root mean squared error and squared correlation. This is like R squared. Yeah. Okay. Let's see. Let's see what it looks like. So I'm going to click the run button. So this one said our root mean squared error is 183.247. So it looks like we have error plus minus like $138. And squared correlation is 0.809. What does that mean? So we can explain the rent with the three variable, 80% of rent. So number of bed, square feet decide around 80% of rent price. And there may be something else explaining rent to price, maybe location, maybe new apartment, old apartment, kind of what. So 80% not bad, still good, but I want to improve this. I want to try something else. So this time, this is what I want to do. This one, I want to distinguish with the other. So I'm going to name this one linear result, linear regression result. And then in the tutorial, I also covered non-linear regression. So I want to test non-linear regression. To save time, you may just copy all this, and then we can paste it here. Then we don't have to repeat this one. So this model will be little different. So let me move this one a little bit to here. No, I think I want to give a space here. Okay. Let's give a little space so we can test it. So try to match with the prior one. Okay, now I want to generate a data, generate attribute. This one, I'm going to move over here. What I want to generate? Right now, my model is by rent, decided by square feet, number of bed, and number of bathroom. But now, instead of just square feet, I want to put the log on square feet. If you look at the market, sometimes your rent price is not exactly linear relationship. It increased by percentage, not by unit. So what I'm gonna do, I'm gonna go to generate attribute. I'm gonna add new one. This one, let's name log square feet. Okay, look at this one. Functional expression, what I'm gonna use, how do I put the log and square feet? Simple. We're gonna type like Microsoft Excel, also do the same way. I'm gonna type ln. Or if you go here, you can find it, but we're just gonna go type here. Okay, let me quickly show here. Okay, here, ln log. So I'm trying to use ln. So you may type or may just click log, and then we're gonna, instead of typing square feet, let's just click this one, square feet. Okay, so we just create a new attribute named square feet of log square feet. Apply. So this is what it looks like. This is our name. This is our formula. So say okay. So now what I'm gonna do in the select attribute, I'm gonna go here. Instead of square feet earlier, since we copy and paste from prior model, I'm gonna remove this and I'm gonna replace square feet with log square feet. So let's add this one. And then set rule, we're following same linear regression, apply model. So I want to see the result. I want to compare results. So this one, instead of linear, let's see log square fit. Something looks like this. Okay. Linear and log square fit. So let's see what it looks like. I want to test this one. So let me move this a little bit. Okay. Let's run this model. So this one, first one, linear. Squared correlation, our R squared is 809. 80% of rent we can explain with our model. But if I put log, let's see. Squared correlation is 0.846. So it looks like we can explain 84% of rent with our model. So this improved our whole model. This looks better. Okay, I'm gonna go back to this one. This looks good, but I want to do a couple more. So let me just copy and paste. I don't want to create again. So again, I'm gonna copy this one and paste. And then this time, this is what I want to do. Rent attribute, it's gonna stay there. I'm gonna do the same thing, but I'm gonna create a new attribute here. And then I need to do one more of these ones. So let's do this one first. And then later, I want to create one more. Okay, first, retrieve rent. It's the same data. General attribute. I'm going to go here. Earlier, we put the log on the square fit, but this time I want to add log rent. Log rent means our target variable in the rent, I want to put log. Sometimes when we increase the percentage of square feet or other variable, your rent also increase by percentage, not unit. So how do I put the log? We're going to repeat the same way. So you can type, or if you prefer to use this one, you can say ln. And this time, we're going to put log on rent. So click this one and apply. So I just create log rent. And of course, we already have a log square feet. Okay. And then I need to make a couple of changes. Select attribute, I need to go here. I notice we have a rent earlier, but instead of rent, I want to use log rent. So this time, I have log rent is decided by log square feet, number of beds, and number of beds. Of course, you can put the log here. I'm just testing only one. Okay, let's see. Set rule, I have to set again because earlier we used the rent, but there's no rent anymore. So we're going to use the log rent as our label. And linear regression, apply model, log square feet, all same. Okay, let's see what it looks like. So first one, okay, I want to go back and change this one. Okay, it's not log square. This one, I want to call log and log because there are two logs. First log is on square feet. Second log is on rent. So when I click the result, I hope you can see linear again. We see around 80%, log square feet around 84%. How about log and log? We see 86%. So compared to prior one, this is actually better. So it looks like our rent to price is not linear. It's kind of log and log relationship. Once you increase the percentage of square feet, your rent to price also increase by percentage. Good. I want to test one more. So I want to connect this one I don't want to create again. So what I decide to, how about this? To save time, I want to use multiply. So I'm going to put here multiply. So if I put multiply here, I can create without creating another one. We can continue to use. So I want to move this a little bit. So I'm trying to look balanced. Okay. And then I want to copy this. So I want to copy all. I want to copy only this one. And then I'm going to go here. Okay, since I already have square foot log and square foot rent, what I'm gonna do, I will select attribute this time. This one, what do you call? I want to call exponential. Exponential means we're gonna put log only rent side. So I hope you can see my tutorial and notebook, difference between linear, log square feet, log, and exponential. So what I'm gonna do, I'm gonna go to select attribute. Earlier, I put the two log and log, but this time, instead of a log square feet, I'm gonna remove this one, and then I'm gonna use just regular square feet to see which model is better. Square feet, number bath, and we put log only rent side. It simply means when square feet baths increase, rent increase by percentage. Okay, apply this one. Set role, we already put the log rent, and then it's the linear regression. This is the apply model and log. So we're gonna connect the result here. Okay, now let's run and see what it looks like. Click the run. So, okay. First one again, 80%. Second one, we saw 84. Third one, improved to 86. I'm wondering our last one, exponential. 805. Okay. So among four model, looks like for me, this is the best model. This one. The log model has around 80%. So this model show the best.